On Thursday, we introduced limits by looking at a table of values for a function. Today, we're going to look at limits by looking at the graph. And the graph of the function can be very helpful in finding limits. There are three different situations here. In the first situation, we have a graph that is continuous. There's no breaks in the graph. This is y equals f of x, and we see that the x coordinate of c is right here. F of c, the y coordinate when x is c, is equal to n. In this case, the limit of f of x as x approaches c is also n. What that means is the graph approaches n as x gets closer to c from one side and approaches n as x gets closer to c from the other side. So the y coordinates are approaching n as the x coordinates approach c. In this case, when you hit c, the y coordinate is n. Here's a second situation. The f of c value is up here. It is not equal to n. But in this case, the limit as x approaches c of f of x is still equal to n. As we come in from the left and from the right and get closer to c in the middle, my y coordinates get closer and closer to n. So the limit is still n, even though the function value at c is not n. In the last case, the function value at c is not defined at all. There's no point where the x coordinate is c. However, the limit as x approaches c of f of x is still n. As we come in from the left and come in from the right, the values of the function get closer and closer to n. You do not have to hit that value in order for it to be the limit. In the second graph, the limit as x approaches c of f of x is n, but f of c is not equal to n. And in the third graph, the limit as x approaches c of f of x is n, even though f of c is undefined. We need to talk briefly about one-sided limits. When c is only approached from one side, we can talk about the left limit and the right limit. The left limit, the limit as x approaches c from the negative of f of x, is called L. What that means is as x gets closer to c but remains less than c, the corresponding values of f of x get closer to L. That's looking at the graph and looking at c only coming from one direction. And if it approaches a value L, that's the left limit. The right limit, the limit as x approaches c from the positive of f of x, is called R. And that's when x gets closer to c but remains greater than c, and the corresponding values of f of x get closer to r. So here we're talking about c is here, and we're coming in from this direction and approaching some value r. In order for the limit overall to exist at c, L must be equal to r. In order to say that there is a limit as x approaches c, we have to have a left limit and right limit that are equal to each other. Some examples will make this clear. In this graph, we have a piecewise function. Looks like part of a x squared graph and then maybe a absolute value that has a negative a. If we look at this, first thing I'm looking for is the limit as x approaches 2 from the negative, so the left limit of f of x. Here's x equals 2. I want to get closer to 2 from the negative side, from the left. As x gets closer to 2, the y coordinates get closer and closer to 3. Then I look at the limit as x approaches 2 from the positive side, the right limit. As x gets closer and closer to 2, the y values again get closer and closer to 3. Since these two values are the same, the limit as x approaches 2 of f of x is 3, because 3 is the number that we're approaching from both sides. This is different from what's happening around 0. As x approaches 0 from the negative side, down here, the y coordinates get closer and closer to 0. But as x approaches 0 from the positive side, the right limit, going this way, the y coordinates get closer and closer to 1. Since those two limits are not equal to each other, if we ask for the limit as x approaches 0 of f of x, we say it does not exist. or you can abbreviate DNE, does not exist. Here's another graph, and we'll do several of these examples. Here, we're going to assume the scale on this graph is 1. The first one is the limit as x approaches -6 from the negative side, so from the left. 1, 2, 3, 4, 5, 6. -6 is here. As I get closer to -6 from the left, the y coordinates get closer and closer to -1. Then I want the limit as x approaches -6 from the positive side. From the right, as I get closer and closer to -6, the y coordinates get closer and closer to 4. So if I ask for the limit as x approaches 6 overall, since these two values are different, we say that limit does not exist. Then we're going to look at what's happening around -3, and it just asks for the limit as x approaches -3 from the right and the limit as x approaches -3 overall. So -3, 1, 2, 3 is here. As we come in from the right, we get closer and closer to -3 in the y coordinates. And if we look, if we did the left limit, it would also get closer to -3. So the right limit is -3. The left limit is also -3. So the limit overall is -3. Then we're going to look at what happens at -1 from the left, from the right, and overall. At -1, as we come in from the left, the y coordinates get closer to 2. As we come in from the right, the y coordinates get closer to 2. Notice they never hit 2 there. That doesn't make any difference for the limit. Because the left limit is 2 and the y limit is 2, the limit as x approaches -1 of f of x is 2. Then look at what's happening around x approaching 1. Here's 1. As we come in from the left and from the right, both sides approach the same value of -1, which they actually hit in this case, since it's continuous at that point. So the limit is -1. Here, we have the limit as x approaches 3 from the left. 1, 2, 3. Coming from the left, this graph is going down and going down forever. So the limit in this case is -infinity. Then look at what happens as x approaches 3 from the right. The graph on this side goes up forever. So then that side, the limit is +infinity. If we want to find the limit as x approaches 3, the left limit and right limit have to be the same. These are not the same. One side goes to -infinity, one goes to +infinity. So in this case, the limit does not exist. Now look at what happens around 8, which is here. If we look at the left limit and the right limit, they're both going down to -infinity. Since it goes down to -infinity on both sides, then the limit as x approaches 8 of f of x is -infinity. You can have a limit of infinity or -infinity as long as the graph is going in the same directions on both sides of where that asymptote is. Today's homework is some quick worksheet problems. This should not take you very long today.